Hello friends, welcome to another interesting, easy to understand, at the same time important concept in your competitive examination point of view, that is diodes, forward and reverse bias. See, nowadays questions are being asked frequently based on these concepts in almost all competitive examinations. So let's have a look at it quickly. Here we go. First, let us see what is a PN junction diode. See, diode indicates it's a device with one junction and two terminals. Diode, two valves. When a P-type semiconductor is properly sandwiched with an N-type semiconductor, a junction diode is formed. Right? A P-type semiconductor is brought in contact with an N-type semiconductor. That forms a PN junction. So it looks like this. See, on the left side you have P-type material, on the right side you have N-type material, P-type semiconductor, N-type semiconductor. But at the junction, see, recombination of holes and electrons take place in this region. Therefore, this region becomes a region with no mobile charges. This region is depleted from mobile charge carriers. To the left of it you have holes, and to the right of it you have electrons, right? But within this region, a recombination of holes and electrons takes place, which leads to a barrier. The potential difference is maintained across this region, depleted region, that is called potential barrier. So at the junction, electrons diffuse towards P region and holes diffuse towards N region, and they recombine with each other in this region, not throughout this diode. So this leads to the formation of a thin layer around the junction, and this thin layer is called the depletion region. That's what is shown here. Okay. So the potential difference developed across this depletion region is called the potential barrier of the diode. Potential barrier, VB. Is that clear? Now, see, this diode can be connected in two different ways in a circuit, and the circuit symbol of the diode looks like this. This is P side, and this line and the arrowhead, this indicates N region. Remember it like that. P and N regions. So it can be connected in two different ways. That is called biasing. There are two ways to bias it. One is forward bias, another one is reverse bias. So in forward biasing, see, positive terminal of the battery as shown here in the figure. This is positive terminal of the battery is connected to the P region, and negative terminal of the battery is connected to the N region of the diode. Then the diode is said to be in forward bias, provided if the cell EMF is greater than the barrier potential, VB. If the positive terminal of the cell is connected to the P region and negative terminal of the cell is connected to the N region, and the EMF of the cell is greater than the barrier potential, then the diode is said to be in forward bias. See, forward bias circuit symbol looks like this. This is positive, negative of the battery. Positive is connected to P region here, negative is connected to N region. That is forward bias. But sometimes what happens, see, without connecting a battery, two different potentials will be applied across these P and N regions. For example, a diode like this. Here it is given plus 5 volt and here it is given plus 2 volt. See, both are positive potentials, plus and plus. But one is 5 volt, another one is 2 volt. When higher potential is applied towards P region and lower potential is applied towards N region, then also it is considered as forward biased. Only thing you need to check here is whether it is higher compared to the other value or not. High potential on the P side, low potential on the N side will make it forward biased. Understood? Right. Now, see, in this biasing, current flows continuously through the junction due to majority charge carriers. So diodes will conduct in forward biased mode. Remember that. They conduct in forward biased mode. Applied voltage is opposite to the built-in potential, and width of the depletion layer decreases in forward bias. Very important point. Width of the depletion layer decreases in forward bias mode, and the barrier potential graph looks like this. Without battery connected, actually this is the potential difference V0. But when battery is connected, the potential difference decreases by this value V. So effective height of the barrier potential would become V0 minus V. Barrier height is clearly decreased and the effective barrier height becomes V0 minus V. This is V0 minus V. That is the effective height of the barrier. Okay. Now, majority carriers conduct the current in this case. Minority carrier injection takes place in forward bias mode. And especially in forward bias mode, diffusion current flows due to electrons as well as holes. That is the speciality of the semiconductor devices, diodes. In conductors, conduction is only due to electrons, but in semiconductors like diodes, transistors, conduction happens because of both electrons as well as holes, and the current established in this case in forward bias mode is in the order of milliampere range. Current is in milliampere range, whereas in reverse bias it will be very less. It will be in the order of microampere. Right. Now coming to the reverse bias, the name itself indicates reverse bias. When positive terminal of the battery is connected to N side of the diode and the negative terminal is connected to P side of the diode, then the diode is said to be in reverse bias mode as shown here. See, positive terminal of the battery is connected to negative side. Negative terminal of the battery is connected to positive side of the diode. That is a reverse bias. So in reverse bias, diode does not conduct. Ideal diodes will not conduct at all. The circuit symbol in reverse bias mode looks like this. See, this negative terminal of the battery is connected on P side and positive terminal of the battery is connected on N side. It is connected in reverse mode. That's what is reverse bias. So in this mode, no current will flow across the junction. Okay, for ideal diodes. Or even if there is small current in the order of microampere range, that is due to minority charge carriers. Minority charge carriers. So in forward bias and reverse bias, the diode conducts in forward bias mode and does not conduct in reverse bias mode. It blocks the current in reverse bias mode. Whose function it is? Whose feature it is? See, conducting in one mode and not conducting in another mode. That is simply a switch. Switch conducts in on mode and doesn't conduct in off mode. Isn't it? So a diode acts as a switch. Diode acts as a switch. It conducts in forward bias mode and does not conduct in reverse bias mode. Okay, next. The direction of applied voltage is same as that of the barrier potential in reverse biasing, and width of the depletion layer increases in this case, whereas in forward bias mode, width of the depletion layer is used to decrease, but here it is increasing. The drift current is in the order of microamperes. Very small current will be passing through the diode. If it is an ideal diode, in the case if question says ideal diode, you can take it as current is equal to 0. The diffusion current decreases enormously in reverse bias mode. Understood? Right. So just like forward bias, here also if it is not the battery connected, you need to check the potential supplied across the diode, high and low values. See, if a lower potential is applied on the P side, this is P side, this is N side of the diode. If a lower potential is applied like a minus 7 volt here and a minus 3 volt here. See, both are negative potentials. But compared to minus 7, minus 3 is higher. So higher potential is on the N side, lower potential is on the P side. Then it is said to be in reverse bias. Or sometimes one can be positive, another one can be negative. See, plus 7 volt and minus 3 volt. Plus 7 volt on P side, minus 3 volt on N side. Higher on P side, lower on N side. That makes it forward biased. If you have minus 7 and plus 3, minus 7 is clearly less compared to plus 3. So lower potential on P side, higher potential on N side. Then this diode is in reverse bias mode now. Clear? It all depends upon the potential supplied across this diode. If it is not the battery connected, we'll have questions based on these models also. Now, in reverse bias mode, the barrier potential increases, barrier height increases clearly. See, without the battery connected, V0 is the potential across the diode, but when battery is connected, it increases by another V. So, effective barrier height becomes V0 plus V in this case, in reverse bias mode. Understood? Yes. Now, let's have a look at some questions asked in previous JEE main. For more such interesting videos, you can subscribe to our channel Time for IITJEE NEET. That definitely enhances your subject knowledge as well as your score in competitive examinations. Here is your first question that appeared in recent JEE main. The value of net resistance of the network as shown in the given figure is net resistance. The question is about the resistance in the circuit. See, the two potentials applied are minus 6 volt and minus 8 volt. Minus 6 is high compared to minus 8. So this side you have high voltage and this side you have low voltage. As per this, there are two diodes, name it as D1 and D2. D1 is clearly in forward bias mode because higher voltage is on P side and a lower voltage, lower potential is applied on N side. So this is forward bias. But when it comes to D2, high voltage is applied on N side, low voltage is applied on P side. Reverse bias. So in reverse bias mode, no current passes through this path. So directly you can remove this path. Okay. Then the upper two paths are possible, are available for the current to pass through. Diode is in forward bias mode, D1 is in forward bias mode. So there are two resistances here. What is the effective resistance? When these two resistances are considered, clearly they are parallel to each other. When it comes to effective resistance in parallel combination, it's R1 R2 by R1 plus R2. Yes, the two values are 15 and 10. So 15 into 10 by 15 plus 10. That is 150 by 25. Nothing but 6 ohm. So correct answer is option B for this. Okay. So this is the question purely based on forward and reverse bias modes of the diodes. You need to identify which diode is in forward bias mode, which diode is in reverse bias mode. Then easily you can answer these questions. Another question, which of the following circuits is reverse biased? Which is in reverse bias mode? What is reverse bias? Higher potential has to be applied to the N region, lower potential has to be applied to the P region. Now here is the diode. This is P side, N side. To the P region, there is plus 2 volt. To the N region, minus 10 volt. Plus 2, minus 10. So, higher potential is applied on P region and lower potential is applied towards the negative region, N side of the diode. Then clearly it is forward biased. Okay, question is about reverse bias. See the second option. On the negative side, N side, minus 5 volt is applied. But on the P side, it is connected to the ground. What is the potential of the ground? Ground potential is considered to be 0 volt. Okay. So 0 volt, 0 on P side, minus 5 on N side. Minus 5 is less than 0. So lower potential on N side, higher potential on P side. Clearly it is also forward biased. Coming to option C, plus 2 on P side and on N side you have 0 volt. So higher and lower on P and N. Clearly forward biased. Okay. Coming to the last option. By this time we'll come to know the answer. When these three are forward biased, obviously fourth one will be in reverse bias. Let us check that. See, plus 2 volt on P side and plus 4 volt on N side. So clearly higher potential is on N side, lower potential is applied on P side. That's what is reverse bias. Okay, so right option here is option D. No need of any calculation, nothing. Directly by observing these potentials, you can answer these kind of questions. Another one. What is the current through the battery in the circuit shown below? Current through the battery. If I is the current passing through this, what is the current? See, here are two diodes, D1 and D2. For these two diodes, higher potential is applied on the P region and lower potential on the N region. This is P side, N side. On N side, it is negative terminal is connected. On the P side, positive terminal of the battery is connected. So clearly these two are in forward bias mode. So in forward bias mode, diode conducts perfectly. Okay. So current will pass through these two paths. Now two resistances 20 ohm each are connected and these two are clearly in parallel combination. Just now we have seen what is the effective resistance in parallel. It is R1 into R2 by R1 plus R2. That means 20 into 20 by 20 plus 20, 40, which comes out to be 10 ohm effective resistance. Potential is given. What is the current? Using Ohm's law, I is equal to V by R. It's 5 by 10, 0.5 ampere. So 0.5 ampere is here in option D. Understood? Right. Now let's see some questions that are asked in NEET entrance. For any queries regarding online courses, you can visit our website www.timeforeducation.com. You can subscribe to our YouTube channel, that is Time for IITJEE, for more such interesting videos. See, this is the question that appeared in a recent NEET. The given circuit has two ideal diodes connected as shown in the figure. The current flowing through the resistance R1. See, here is resistance R1. What is the current flowing through the resistance R1? With respect to this battery, how are these two diodes D1 and D2? See, plus 10 volt here, minus 10 volt here. Plus 10 volt is applied towards the N region and negative terminal is connected to the P region here. So clearly D1 is in reverse bias mode. D1 is reverse biased. What about D2? See, positive terminal of the battery is connected to the P region and negative terminal of the battery is connected to the N region. So D2 is forward biased. It is forward biased. So conduction happens only through D2, and as D1 is in reverse bias mode, no current will pass through this. Okay. Now whatever current passes through R1, that definitely passes through this R3 and comes this way. So in this path, what is the effective resistance? Here you have 2 ohm and here another 2 ohm. 2 ohm plus 2 ohm, that is 4 ohm. Net resistance R is 4 ohm and the potential applied is 10 volt. Question is about the current through the resistance R1. That's what is the current passing through the resistor R3 as well as current through the cell or battery. Right. Using Ohm's law, I is equal to V by R, that is 10 by 4. 10 by 4 is 2.5 current measured in ampere. So 2.5 ampere is here in option A. Right answer for this question is option A. Another question, which of the following represents forward bias? This time forward bias. Already we have seen a question similar to this, that was reverse bias. Now forward bias means higher potential has to be applied to the P region and lower potential has to be applied to the N region. For a diode, this is P region, this is N region. Now on P side you have minus 4 volt and on N side minus 3 volt. Which is higher, minus 4 or minus 3? Minus 3 is higher compared to minus 4. So this is reverse bias. Right? This is reverse biased. Coming to option B, minus 2 on P region and plus 2 volt on N region. So this is also a reverse bias. Isn't it? And Coming to option C, on the P side you have plus 3 volt, on the N side you have plus 5 volt. Higher potential is applied to the negative region, lower potential is applied to the P region, N region and P region. So this is also reverse bias mode, isn't it? Coming to the last option, on the P side you have 0 volt, on the N side you have minus 2 volt. Compared to minus 2, 0 is higher. So higher potential is applied to the P region and lower potential is applied to the N region. So that makes it forward bias. So question is about forward bias, which represents forward bias diode. So clearly the last option, option D, is in forward bias mode. The remaining 3 are in reverse bias mode. Understood? And as I told you at the beginning, this is such an interesting concept and very easy to. Okay, so practice this kind of questions so that definitely you can get correct answer for these questions and score well. Wish you all the best. Thank you very much for watching. See you in the next session.